A very good morning to all of you. Welcome back to my channel. This is Shivam Shukla and here I am to solve a problem on engineering mechanics. It's a problem on equilibrium, problem on beams type 4. To find the support reactions of a beam which is consisting of both uniformly varying load, that is UVL, and trapezoidal load, which is a combination of UDL and UVL. Let's see how the question statement goes. Find the support reactions at point A, which is a hinge support, and B of the given beam, which is a roller support. Now this question was asked in May 2018, question number 4A, 8 marks. Let's see how the problem can be solved. As you can see, this is the questions diagram. What are we supposed to find is HA and VA, because it is a hinge support. So two reactions on it, HA and VA, and a roller support. So a reaction, that is RB. Now the first step will be to draw the free body diagram. Let's see how the diagram can be drawn. So now at various points, I'll just naming the point. This is point A over here. This is point B over here. Now what is HA? What is VA? One by one, let's write it. This I can mention it as VA. The horizontal reaction at this point will be called as HA. Okay. Okay. Now there will be only a normal reaction called as RB over here. Now moving ahead, one by one, let me show whatever the forces or the loads are there. So this is one of the force. I can just mark it, which is 12 kilonewton, like this. 12 kilonewton, making an angle of 30 degrees with horizontal. So now I need to resolve it. So it will be resolved as a horizontal component like this and a vertical component like this. So this will be 12 cos 30 and this will be 12 sin 30. Okay. Apart from this, now we are having this as the entire triangular loading, which is a uniformly varying load, and this is a trapezoidal loading, which is a combination of UDL and UVL. Now friends, let us see how we can resolve, how we can convert this loading into a point load. So triangular loading, since it consists of two parts, let us just divide it into separately with 2 point loads. So this part I'll be considering first. Only this right angled triangle, I can see this one, okay. So this will be divided, converted into a point load as half into base into height. So half into W into L. So now half into W is the intensity 10 into L, which is 1. So now it will be 5 kilonewton. It will be converted into a point load. So that is why this value is going to be 5 kilonewton. Again on the other side, I'll be considering the other triangle now, which is this one. Only this much part I'll be considering now. This right angled triangle. Again the formula will be half into W, which is 10, into L, which is 2. So 5 into 2 is again 10. Half into 10 into 2. So 2 gets cancels. So it will be 10 kilonewton. I can show the point load over here. This is 10 kilonewton like this. Okay. Going ahead with the further part. I'll just mark the points so that there should not be further confusion. Now if I convert this into a point load, uniformly distribute, this part only I'll be considering first, which I can say it as a part of UDL only this much. Okay, so if I convert this into a point load, it will be the formula as that of an area of a rectangle. It will be W into L. So 10 into 3, which is 30, exactly from here till here, it will be acting in the mid. So I can show it. I can show it like this. So it will be 10 into 30, 30 kilo Newton. Last but not the least, this upper triangle which is left out. Let me mark this. This upper triangle I'm talking about. So it will be half into W. W is what? 20 minus 10, only 10. So half into 10 is 5. 5 into 3 is 15. So over here, it will be acting over here. Now friends, why I am showing it like this? The reason I'll be telling you one by one. Let me show the distances now. Let me show all the distances one by one. If I want this, so this will be the first line that I'll be making. The second one, the third one is already there. Fourth, fifth, this one, this one, this one. Okay. Now if I'll be showing the distances, I just need to make a line from here and here and this. And now simply I would be extending, just to avoid the confusion part. What I'll do is I'll just extend the lines so that the distances become clear to everyone. Okay. Okay. So now let me just write down. If I am seeing from here, at a distance the point load was L by 3 from this height part, height of the triangle, L by 3. So 1 divided by 3, if I can do the calculation, so it will be 1 divided by 3. So it comes out to 0.333. So it will be 0. I can just show the marks so that accordingly the distances can be shown. Okay. So 0.333, 0.333 meter. What about this? So it will be 1 minus 0.333. 1 minus of answer. It will be 0.666. 0.666. Of course, the values are in terms of meter. What about this? This is 2. So from here the distance will be L by 3. So that will be 2 divided by 3. So if I say it, 2 divided by 3, it is nothing but 0.666. This particular distance is 0.666 meter, and 2 minus of answer will be giving me 1 point. This rest of the distance is 1.333 meters. Now this is 0.5, 0.5. These distances are not going to change at all. So I will be mentioning those as they are. 0.5, 0.5 meter, 3 meters. This 30 kilonewton was exactly at the center. So this was 1.5 meter. Now it was, this particular load was at a distance of L by 3 from this end. So 3 divided by 3. So it was from here 1 meter. And over here the left out distance is only 0.5 meters. So this distance will become 0.5 meter. Just for checking the calculation whether it is correct or not, let us tally the entire distance of the beam, entire length of the beam. 1 plus 2 is 3. 3 plus 1 is 4. Plus 3 is 7. So again, if I take this entire distances, so it will be by default, length has to come. So 0.666 plus 0.333 plus 1 plus 0.666 plus 1.333 plus 0.5 plus 0.5 plus 1.5 plus 0.5 plus 1. So friends, yes, the distance is coming out to be exactly 7 meters. So let's go ahead then and get the values one by one. Let's do the calculation. Go to step number 2. So everyone over here. Okay. Step number 2, I'll be writing it now. So step 2, applying conditions of equilibrium. Applying COE. So first condition that we always apply is summation of moment about a point is equal to 0, acting in clockwise sense as positive. Why did we apply the moment about point A? Because it consists of maximum number of unknowns. So now starting with this, the diagram is there in front of us. So it will be minus 5. Why? Because 5 is causing the body to rotate in anti-clockwise sense. Minus 5 into 0.333 plus 10 into 0.666. 12 cos 30 is not going to come because it is acting on the line of action. But yes, 12 sin 30 will be coming. So plus 12 sin 30 into the distance, that is 1.333. So 12 cos sin 30, if I see friends, from A it is at a distance of 2.5 meters. Okay. So yes, into 2.5, again plus 30 into 2.5 plus it will be 0.5 and 1.5. 2.5 plus 2, it is going to be that is 4.5 into 4.5 plus 15 into 5 minus RB into minus of RB into 4.5 plus 1, it is going to be 6 into 6 is equal to 0. Friends, just for our calculation sake, just let me write the proper values. This will be 0.667. Again here also it will be it is going to be 0.667. That's it. So I'll be just doing the corrections as this is okay. 10 into 0.667 it's gonna be, because the round figure has to tally properly. That's it, nothing else. Let's go ahead with the calculation. Therefore RB is equal to, let me do the calculations. So it's coming out to be minus 5 into 0.333 plus 10 into 0.667 plus 12 sine of 30 into 2.5 plus 30 into 4.5 plus 15 into 5 is equal to whatever the value comes. It comes around 230.005. It will be going on the other side. It will be coming as minus. So I will be writing it as minus of 230.005 divided by minus of RB is already there, divided by 6. So this minus gets cancels out. And friends, here the value of RB came out for me is, therefore RB is equal to 230.005 divided by 6. 38.334. 38.334. Friends, please don't forget to write the units. So it will be, it is mandatory. So kilonewton. So I can write it as yes, it is acting upwards. Now let us apply the second condition of equilibrium. That is step number 3 for me. That is summation of fx is equal to 0, acting towards right as positive. So it will be HA minus 12 cos 30 is equal to 0. Very easy. I can write it HA minus 12 cos 30 is equal to 0. Therefore, HA is equal to, so it's coming out to be 12 cos 30. 12 cos 30 10.392. So it will be 10.392 kilonewton. Yes, it will be acting towards right as per our assumption. This is coming out to be correct. Now step number 3, that is summation Fy is equal to 0, acting in upward sense as positive. Let's get the value of Va now. Let's get the value of Va. So now it will be one by one. Let's see the diagram and then write the equation. So it will be minus 5, minus 10, minus 12 sine 30, minus 30, minus 15, plus RB and plus VA. So let me write it. It is minus 5 plus VA minus 10. Okay. Minus 12 sine 30, minus 30, minus 15. So here it is minus 12 sine 30 minus 30 minus 15 plus RB, which is 38.334 is equal to 0. Therefore, VA is equal to, so let me do the calculations, minus of minus 5 minus 10 minus 12 sine 30 minus 30 minus of 15 plus 38.334. So VA will be, if it goes on the other side, yes, it is coming out to be 27.666 kilonewton, and of course the value has come out to be positive. That means it will be acting in upward sense. Now friends, let us see how the marks are going to get distributed for this particular problem. Just let me write it properly one by one. This entire free body diagram will be giving you 2 marks for the FBD. Then one by one, every step, this along with the equation will be giving you 2 marks. Entire problem is for 8 marks. This HA value is comparatively easier. It will be giving you 1.5 marks. VA value again 2 marks. More half mark will get added in the questions diagram, that is FBD. That is 0.5 marks. So total, this is the way how the marks are going to get divided in the problem, and this is the way how the problem is getting solved. So friends, please do see to it how the problem gets solved, and please do like, subscribe and share this video. Thank you for watching this video.